So in this presentation, we will be discussing the various networking standard protocols utilized by Q-SYS systems for audio, video, and control. Those protocols will then kind of lead into the networking requirements needed to support those protocols on a QLAN network. At the end of this presentation, we'll also provide a summary of kind of a sizzle reel, if you will, of the networking requirements and highlight some of the most common networking issues that we run into so we can kind of boil it down to kind of some bullet points there. We're going to go over a lot of topics. Obviously, networking is a pretty vast topic to speak about in general. And so we are going to touch on a lot of topics. So this is going to be somewhat high level and somewhat fast paced, but keep in mind, all of these topics and all this information that we're going to go over in this webinar are available in our help file. And I'll provide you a link to that help file location here shortly, or at least at the end of the presentation. So if you do need to do a deep dive into any of these topics specifically or get a little bit more information than what we touch on in this presentation, that will be kind of your single source of truth for Q-SYS networking. If you do have any questions, I encourage you to ask those questions in the Q&A portion of this webinar, not the chat, but the Q&A portion. My teammates here, Jason Kleiman and Frank Pajak, are nice enough to be panelists, and they will be manning the Q&A section of this. Yeah, wave, say hello. Oh, awesome. And so they will be helping me while I do this presentation. They will be firing away answers to your questions. If there are any questions that stump the band, if you will, and perhaps we can't get a quick answer, reach out to us in the Q&A or even follow up with us after this webinar. And if we need to get our networking support team involved and get those answers for you, we'd be happy to do so. Just a little bit of background. So myself, hi, I'm Bill Crow. Jason Kleiman and Frank Pajak, we make up a team where we provide design assistance through our consultant liaisons as well as our area managers to our integration dealers. And so if you have reached out through them for design assistance, design reviews, or ease models of your various projects, you have perhaps worked with us in the past, even if you weren't aware that you have. But if you have made any of those requests through your consultant liaison or area manager, you very well may have worked with us in the past. So we help our system designers every day with a lot of these type of questions and kind of help them kind of set them up for success. So hopefully that gives you a little background of who we are and what we do. And so with that, let's kind of jump into this. So networking requirements and recommendations. So what we're going to start with in this presentation is, get my laser pointer working. There we go. Is we're going to first go into the QLAN protocols, like what data are we putting on the network? We're going to run through that, and then that kind of dovetails into the requirements. So let's jump into QLAN protocols. So starting with audio, so our QLAN audio streams are UDP unicasts from source to destination. Those streams are 3 to 26 megabits per second. The reason there's that range there is because each of those streams could consist of anywhere between 1 and 16 audio streams, or audio channels rather. One thing to keep in mind is that if you are doing redundant networking, that core processor has to create identical duplicate streams on both the primary and the backup network. And so please keep that in mind if you are ever specifying your core model and needing to figure out which model can handle that particular number of network I/O channels, because each one of our core models has a specific limit as to how many of those network audio channels it can handle. And so just keep in mind that if you are doing redundant networks, that those streams count twice. That duplication of streams also affects all of our core models up to the 5200. So be sure to double those audio channel counts when you are specifying your core models. One thing to keep in mind is that these audio packets of data have to be able to traverse your network in 280 microseconds or less. And so one thing that does drive as far as a requirement to keep that propagation delay, if you will, under that limit is a 1 gigabit network is required to maintain that low of latency. So if you look at those per stream bandwidth amounts there, you may very well think that, well, I could, 100 base T network would be plenty enough for the audio channels for a particular project. And so while that may provide the bandwidth, you also need to keep in mind that that 100 base T network is likely not going to be able to support that 280 microseconds that we need to be able to have this data traverse your network. Another protocol that we use is PTP clocking. And so QLAN audio packets or audio systems use PTP v2, which is the exact same timing protocol as AES67 and ST2110. For those of you that are familiar with Dante, Dante uses a similar format, PTP v1, whereas QLAN and AES67 use PTP v2. For those that may not be familiar with PTP clocking, basically what that is there's a clock master on the network that then sends out clocking packet data to all the peripherals, and so they can synchronize their internal clocks. And so for that to work well, that network needs to be able to provide support for UDP multicast on the network with the destination IP address that's shown in this slide. Now, the clock leader that's generating and sending out these packets, they send out less than 100 packets per second and less than 100 bytes in each packet. So it's not much of a bandwidth issue, to be honest. So the most important thing to keep in mind when it comes to PTP clocking is the latency. So again, that 280 microsecond latency, these packets have to be able to traverse the network in that time or less. And even more importantly, to be honest, is your network needs to have low jitter. And basically what jitter means is when these PTP packets are being sent out from the clock master down to each of the peripherals of the followers, they are constantly calculating the round trip time in your network. And so they can offset for that and correct for that amount of delay. Well, if the time it takes for those data packets changes in any significant manner on your network, then all of a sudden those calculations start to fall over and you can have some instability in your network. So it's really good to have a stable network, one that doesn't produce a lot of jitter, and we'll show you some means and methods to produce that successful output there. As far as QLAN video streams, so each one of our video endpoints that's functioning as an encoder is functioning as an RTSP server to stream out that video. We use RTSP server with TCP to listen for stream requests. And then the actual stream is in a format called RTP. Those video streams are point-to-point from encoder to decoder, and they do not pass through the core processor. We do get questions quite often about core processors being able to handle, X number of video streams. And to be quite honest, as far as the core processor is concerned, it's mainly a control exercise because the core is just telling the decoders which video stream to subscribe to. And so those video streams do not pass through the core. That video data goes directly from encoder to decoder. Those video streams are unicast or multicast, and that is determined by the schematic in your Q-SYS designer software. So if your schematic if you have enough destinations to require a video encoder to be in multicast mode to be able to hit all of the various decoders, when you compile your Q-SYS designer file, it will go ahead and set those encoders to output multicast. And unless you are dealing with an extremely simple and or small Q-SYS video design, more than likely these video streams will be multicast. So go ahead and just assume for the most part that any Q-SYS network that has video on it that those video streams will be multicast. So one thing, huge thing to keep in mind, obviously, is that the stream bit rate usually hovers around 650, can be up as high as 800 megabits for 4K or UHD resolutions. But if you're doing 1080p, each one of those streams is about 250 and typically maxes out at about 300 megabits. So there are some bandwidth concerns that you need to provide for on your network. So as far as our camera video streams, these are multicast, and we have a range of IP addresses shown on the screen that we use for our multicast streams. Those are H.264 streams, and those bit rates are user configurable between 1 and 30 megabits. Also, one thing to keep in mind is that our cameras also provide a second preview stream, and that data rate is between zero point 0.5 to 2 megabits on the network. And so those preview streams are typically, if you are familiar with our preview windows on our touch panels, or even if you open up VLC on a computer, you can then view those preview streams. And as far as control, so as far as Q-SYS control, the main exercise here is kind of memorizing your ports, if you will. These aren't necessarily very bandwidth intensive, but it's things to keep in mind. So communication between our core processors, UCI viewers, and touch panels, as well as our Q-SYS Designer software. We use HTTPS, so obviously we need port 443 open on the network. There's also a Q-SYS control binary secure communication between redundant core processors, touch panels, and UCI viewers. So that's a TCP connection on port 1704. As far as external control protocols, so if you needed Q-SYS to be controlled by a third-party control system, which there's really no reason you should ever want to do that since Q-SYS is such a powerful control platform, but if you are forced to, we do have two separate control APIs that we support. And so you can control Q-SYS through ECP or external control protocol. And that's a TCP connection on port 1702. We also have a little bit more full-featured and more modern JSON-based control API called QRC, and that is on port 1710. Again, this is basically control traffic, uses less than 10 megabits. I would say probably far less than 10 megabits, to be quite honest. So typically, if we run into any issues with these on a network, it's mainly just because there's a firewall blocking some of these ports. One thing to keep in mind with Q-SYS control is that this list here does not account for any custom programming or plugins. Those can use anything from HTTP, Telnet, SSH to connect to some third-party device. And so keep that in mind that this list is not completely comprehensive as far as any custom programming or any plugins that you've added into your design. All right. Another protocol that we use is QLAN on QLAN networks is device discovery. So for those of you that are hopefully familiar with our Q-SYS Designer software, and you can do a search for all the devices on the network, and it will populate that list of all the devices that it has discovered. Well, this is how that works. And so basically what Q-SYS Discovery or QDP is it will send out a UDP multicast query on the network, and then any devices that then receive that multicast query will respond back as a unicast response, basically saying, hey, I'm here. This is my host name. This is my IP address. And so that is how a Q-SYS design file, once it's loaded onto the core and running, it will then be able to discover those peripherals on the network, determine by host name if it is a part of that design. It can then send firmware if needed and also connect and get your design running. And so that's basically a quick and easy way for all of our devices to find each other on the network and go ahead and automatically connect. So these QDP packets are sent about every second, and that's sent from cores, peripherals, and a PC that's running the Q-SYS Designer software. Again, this is a multicast protocol that needs to be supported. And so as soon as a Q-SYS device joins a network, it will then join that multicast group so that the network will then send any of those multicast QDP packets to that device, and that's just basically how they identify and find each other. All right, so those are the protocols. And so now let's jump into a little bit of what it takes. What features and functionality does your network need to support to then to be able to provide and support those protocols? And so, first and foremost, let's talk about bandwidth. So, bandwidth in particular is mainly an issue when it becomes an issue is with our video systems. And so, one thing to keep in mind is that these requirements, we're going to need network switches that include non-blocking wire speed gigabit Ethernet. And so, what does that even mean? And so, basically, what a non-blocking full wire speed switch, what that means is that the back plane of your network switch has enough bandwidth that every single port on that network switch can run at full bandwidth and there are no bottlenecks. And so basically, it's a way to say if I hook up nothing but a bunch of video encoders to this network switch and push out all this data, that the back plane of that network switch can handle that and forward those packets and not get basically overwhelmed. The connections between the network switches, uplink ports, or inter switch links must support the aggregate bandwidth plus some overhead. And so, a lot of times when we see network designs, uh, some of the issues that we run into are mainly where the bottlenecks really reside are in those uplink ports between your switches. So it's not terribly difficult to get the full wire speed network switch, but if there's only a 1 gig link between two switches and you're pushing 4K, 60 video at 800 megabits, you can find out real quick how easy it is to flood that 1 gig link between your switches. Routing one video stream across that uplink would work fine, would work well, but as soon as you make a second route, you could easily flood that uplink port. So if you are dealing with the Q-SYS video on your network, it behooves you to calculate how much bandwidth you're going to send across those uplink ports to make sure you have enough bandwidth for that. We do recommend having at least 20% overhead, which works out well. If you're doing 4K 60 video at 800 megabits, then you simply just say, I need 1 gig of bandwidth for every video stream that I intend to route across this video uplink. So here's a little bit of an example of that calculation. So on the left side of your screen, we have our encoders here, of which there are 10. And then we have our decoders over here. And here's our uplink connection between these switches. So if this was a 4K 60 or UHD design and we wanted to support those resolutions, we could count basically 1 gig for each of these, which total is 10. So we would recommend at least a 10 gig uplink connection between these two switches. And then that would provide not only the bandwidth for those video streams, but also a little bit of overhead that we would recommend. So quality of service. So we had mentioned before about clocking packets and jitter, and the quality of service is how we can set a network up to provide excuse me, those low levels of jitter. So QoS is required to prevent non-real-time bulk communication from affecting performance of time-sensitive clocking audio and video traffic. So basically what that means, what we mean by real time is that things that require extremely low latency. That's going to be your clocking packets, that's going to be your audio streams, and your video streams. And QoS provides us the ability to rank those. And so in particular, if you have a network with an AV network with more than one switch, it is extremely critical for you to set up quality of service on that network, because now all of a sudden those uplink connections between your switches could very well be a bottleneck, not only for bandwidth, but could put jitter in those packets where the time it takes to traverse your network starts to change because someone decided to from the marketing department wanted to back up a 4K video file uncompressed to some archive server, and now all of a sudden your network is absolutely flooded with data. And so QoS can kind of help prevent something like that from causing issues. And so with QoS, you have your diffserv or DSCP values for packet classification. In Q-SYS Designer, you can set these DSCP values. By default, they're going to be set to the QLAN values, and we'll go into this in a little bit more detail here in just a few minutes of what those values are. So those DSCP values match that of AES67, but you can also set those values to match Audinate, or you can customize those values. And so the reason you would want to do that is if you have an audio network or even redundant audio networks, and you know that you're going to need to support Dante traffic, then you can set your Q-SYS designer file up here instead of QLAN default. You can set it to Audinate, and therefore your Q-SYS system will use the exact same DSCP values for QoS as Audinate. So then when you set up these values, you just set them up for Audinate instead of having to kind of figure out, well, how do I set it up for QLAN and Dante? You can just set it up for the Audinate default values, and Q-SYS will match those. Your network needs to provide at least or provide strict priority and at least 2 levels of values of DSCP values. And so I'll show you what that looks like here. So here are the DSCP values that we tag our data with by default for QLAN networks. And so we would want you to set your PTP clocking. PTP is always going to be the highest priority, and those DSCP values 46. Second would be your audio streams at 34. Third would be video, and then control would be lowest or best effort. If you go into your Q-SYS Designer software and you set it to match the audio default, now here are the DSCP values that your Q-SYS system will follow, and this matches the standard for Audinate's Dante. And so this, if you are having to run QLAN audio and Audinate Dante on the same network, you would definitely want to do this just to simplify your network configuration. All right, we've mentioned multicast quite a bit. And so let's jump into a little bit of what does it take to kind of wrangle multicast on a network. So Q-SYS supports IGMP v2. And so for that to work on your network, you need IGMP v2 snooping enabled on all of the switches on the network. And your network needs to have one and only one IGMP querier on the network. And for those that may not be familiar with that, I'm going to do a very high level explanation of that. And so basically, the snooping that is running on each switch, they coordinate with the querier on the network to be able to figure out what multicast streams are available on the network, as well as what devices are requesting those streams on the network. And therefore, it will route that multicast only to the devices that have requested it. And so this graphic here I have on the right will kind of explain that. So we have our multicast stream origin here. This network has decided that only these 3 destinations have requested that stream, and so that multicast stream will only be delivered to those endpoints. If your network does not support multicast, what can happen is that multicast stream could be sent out what's called broadcast, and it will flood your entire network. I don't think I would need to necessarily explain how important it would be to not have a 800 megabits multicast video stream broadcast to every single port on a network, but they could be quite catastrophic. And if we are riding the owner's network, we don't want to do that. And so, again, just be aware that, we need to be able to support multicast on these networks to prevent these kind of things from happening. So what also requires multicast support on the network, I mentioned QDP for device discovery. PTP clocking as well requires support for multicast QLAN video streams. If you're doing any AES67 audio on the network, that's going to be multicast. And then Dante can be multicast depending on your routing. And so obviously with all of this listed here, you can see how important it will be to have your network to be able to correctly handle multicast data. So in addition to that, we also highly recommend IGMP fast leave, in particular for if you're doing any kind of video streams on the network. So what IGMP fast leave is that if you have a video decoder and it has already requested a video stream, and then you want to change that route, meaning you want that decoder to then receive a stream from a different encoder without fast leave enabled, that same peripheral could get, or decoder could receive not only the original stream, but also the new stream, and those two would overlap and both be sent to that destination for a brief amount of time. Again, if you have a gigabit network and you're running 4K video, you would then flood that port with two, potentially 800 megabit streams, which that switch port could not handle. And so what Fastlead does is make sure that when you change a video route, that there's no overlap, and so that port does not become flooded. So one thing to keep in mind, so when any Q-SYS device joins a network, it will go ahead and request that it join a multicast group, and then and only then will it redo that if the IGMP querier asks for those details. And where we see that issue is if you first put a device on the network and it can receive either an audio or video stream, I guess in this case it'd be a video stream, and it works for some time, and then that route falls off and you're not receiving it anymore, that quite often points to an issue with the IGMP querier. One thing to keep in mind, since these are multicast streams, if you do need a multicast stream to be able to traverse, either go to a different VLAN or get routed to a different subnet, you very likely may have to enable PIM sparse, or protocol independent multicast sparse mode, which is quite a mouthful. So basically what that is if you have a network that's either segmented in separate VLANs and or subnets, and you need these multicast packets of data to be able to traverse that, then you would need that enabled at the router. Moving on. So as far as network requirements, let's talk about switch hops. So I mentioned before about, you need data to be able to traverse a network in a certain amount of time, as well as we need low jitter for these systems to be stable. And so due to those reasons, Q-SYS supports up to 5 hops, basically 5 switch hops, to get from any Q-SYS device to another. We recommend 3. That's not always practical or possible, but it's a goal. Quite often we can get there, but if network requires more hops, we do support up to 5. Let's see, and one other thing that can help with some network stability, in particular, if your hop counts start to grow, is to be able to position your core processor more centralized in your network. So let's say that your core processor was connected to this core switch at the top of this diagram. You'll notice, now it's only even one switch hop away from the peripheral, as opposed to having a core that's on the periphery of your network and it has to traverse the entire network. That's even more important when we take a look at these diagrams here of 4-hop and 5-hop networks. So we do support up to a 5-hop network. But every time you add a switch hop, that's another potential for some jitter or maybe a little bit more latency. So just keep that in mind. We do support up to 5 hops. And that, with a network topology that looked similar to this, we would definitely lean a little bit harder on that recommendation that your core processor and even your clock master, which would hopefully be your core processor, would be attached to the central, your core switch, just to reduce the number of hops between your core processor and the peripherals. All right, so general recommendations. So here's where we kind of boil it down to kind of the sizzle reel, if you will. It's kind of the big takeaways. So have your core connected to the querier switch. This is a general recommendation, not a requirement. That is for the same reason I just mentioned about the fewer switch hops and all that. So typically a core switch is going to, your core switch would be your querier. And so we have found that networks can be a little bit more stable when the core processor is connected to that query or core switch. Q-SYS does not support jumbo frames. So if possible, please disable jumbo frames on the network. I know some other video platforms require jumbo frames. Q-SYS does not support that, so keep that in mind. We also recommend disabling spanning tree protocol or STP. Basically, what STP is it's a protocol to help eliminate the possibility of network loops. Now, one issue that spanning tree protocol introduces is it does add a little bit of delay and some possible jitter to the network, so that can cause issue with your PTP timing packets. You can enable STP on your uplink ports of your switches. So if a network needs STP and QLAN on it, we recommend at least disabling STP on the ports that are connected to Q-SYS peripherals, but you can still keep STP enabled on the uplink ports of the switches. So you still get the benefits of STP without the increased latency and jitter. We also recommend disabling bandwidth throttling or traffic shaping. Again, that's going to add a little bit of jitter to the network. LLDP, link device discovery protocol. We encourage enabling that for some device discovery as well as PoE negotiations because many of our peripherals are PoE or PoE++. And so we recommend having that enabled. We recommend disabling like green Ethernet or energy efficient Ethernet just because that can cause some of our devices to go to sleep. And typically our devices need to stay connected and online at all times. For a converged network, so if you are oftentimes forced to have an AV network converged with the owner's network, we do highly recommend carving out a separate VLAN for the AV devices. Basically, what that does is provide kind of a sandbox, if you will, where if we need particular QoS values or IP address schemes or anything like that that's custom or tailored to the AV network, we have a VLAN to do that. And what's the saying goes, tall fences make great neighbors. And so if you are about to add a lot of devices to some IT department's network, it's nice to have a VLAN just to give us a safe sandbox to play in. As far as VLANs are concerned, it's not strictly necessary to isolate QLAN, Dante, or AES67 traffic on a network, but it can reduce problems just because, again, we can tailor the settings for that VLAN specific to the protocols that we need to support. I will caution you about carving up your network into a large number of VLANs. I have seen some installations where QLAN audio was on one VLAN, Dante was on another VLAN, AES67 on another VLAN, a separate control VLAN. You know, we get 5 or 6 VLANs in there, and now all of a sudden, what happens when you have a Dante microphone that also needs to be controlled? Or you have, you know, even on our larger cores, you're limited to 4 NICs. And so how could you get a core processor to connect to more than 4 VLANs? It becomes quite difficult. And so while separating traffic onto separate VLANs can be useful and quite beneficial, it's important to not go too far with segmenting your network into just an obscene amount of separate VLANs or subnets. We also recommend against optical network media converters. Obviously, you know, Cat5 and Cat6s are typically, you know, 330 feet. And so there, oftentimes you'll have a cable run that's further than that. What we mean by media converters is typically like a standalone device that then takes the twisted pair and then provides you with a fiber connection that can go much further. Those can often add what essentially is a network hop, which adds latency, possible jitter. And so we've run into issues with those in the past. And so what we recommend is using the SFP ports on your switches and go fiber from the switch instead of using any of these media converters. I would hope that does not need to be said, but we'll say it here. Do not use Wi-Fi. You can imagine with the latency requirements and the jitter requirements, if you go Wi-Fi, all that kind of goes out the window. And so when you're using, if there's any Wi-Fi connections between these connection points, you will run into problems. All right, let's jump into a little bit of the network interfaces on our core processors. Starting with LAN A, why not? Let's start at LAN A. So LAN A is going to be your primary QLAN network. And so as far as a Q-SYS device wanting to connect to Q-SYS peripherals, it's going to want and need to do that over LAN A. Uh, you even have a note here on the slide, if the QLAN network is not redundant, LAN A must be used for all of the Q-SYS peripherals. So LAN A functionality is pretty well defined. Now, LAN B, on the other hand, is where it kind of depends on your design as to what you might be able to do with that. So LAN B can be configured as a redundant network to LAN A. And so that's one possible use case for LAN B. If you do that, then the redundant LAN interfaces, so our LAN A and LAN B shown here, they must be on separate VLANs or physical switches. Typically, they are on dedicated redundant switches because the whole purpose of redundant networks is to reduce the number of single points of failure. So in a case where you have a redundant LAN A and LAN B network, if one switch goes down or one connection fails, the audio system will continue to function uninterrupted. If you do run redundant networks to the same switch, just separated by VLANs, you're defeating most of the redundancy. It would protect against maybe a bad cable, but still, if you're going to the same switch, if that switch fails, it's a single point of failure and your audio network would fall down. Uh, our core processors also have auxiliary LANs. If you are familiar with our older core processors like the venerable 510, the 610, or the 5200, those were labeled as aux LAN A and B. Our newer nomenclatures LAN C and D, but either way, once you get past the LAN A and LAN B, those additional ports are aux LANs. And so those network ports do not support uh, time sensitive protocols such as your AES67, QLAN audio, and Dante. So for the you need to keep the aux LANs for non-real-time data traffic. That can be VoIP, that can be control to connect to a control network. Quite often we see those connected to the owner's network so that if they need access to administer the cores through Core Manager, have access to UIs through an iOS app, and they, say they have an iPad and they want to be able to control the system. Their iPad's connected to their the owner's network. The aux LANs are perfect for those type of connections. One thing to keep in mind is that each one of these network interface cards should not have overlapping subnets. And what we mean by that is that the IP address range that's available to each of these networks or VLANs should not have any overlapping IP addresses. And so the reason for that is if the core processor is attempting to connect to a device at a specific IP address, it will look at the subnet, the IP address and the subnet ranges of each of those connections to determine which NIC it needs to reach out and try to make that connection. So if your IP ranges overlap on any of these NICs, then the core can be confused. It can be somewhat random as to which network interface card it uses to connect to that device. We also see a lot of instances where core processors have multiple gateways defined. So what we do recommend is that you pick one of these network interface card connections and provide just one gateway to that one NIC. Again, it's so that that core processor understands if there's an IP address that's not inside of the local area networks, which NIC do I need to reach out to and which gateway do I need to contact to try and establish this connection? If you run into a situation where you need multiple gateways, We do have what's called static routes. Please look that up in our help file for some more details, but there are ways for you to define which IPs and which NICs you would reach out to make various connections. So there is a workaround for this one gateway limitation. All right, so here's a image of in Core Manager. If you look at the web interface of one of our core processors and you go to the network tab, you will see this. And so there's a couple of reasons why I wanted to show you this. This basically gives you a quick rundown of all the network services that are available in Q-SYS, as well as which network interface on the core it's actually enabled. And so there's a couple of reasons you want to look at this. Not only is it to be familiar with the services and the port numbers, but this works as an extremely quick cheat sheet. If you're having any connection issues or your IT admins say, okay, what ports do you need open on your network? Here's a quick cheat sheet of the services and the port numbers specific to that service. And so I've often done this exact same thing where I'll take a screenshot of this and send this to the IT folks, and they get a quick rundown of all the protocols and all the IPs and ports that we are going to use. In addition, you can go to the management tab and disable these services on these NICs independently. And so where that really comes into great benefit is if you are connecting to an owner's network, let's say you have a standalone AV LAN for all your Q-SYS devices and Dante and all that stuff, but you do need to connect to the owner's network. You can go in and individually turn off any of the services that you do not need to run on the owner's network, such as Q-SYS device discovery or a control binary, that kind of thing. So for a couple of reasons, it makes us less chatty on their network, but it's also good practice from a security standpoint because you don't necessarily want to leave an open port on a network to allow a connection from anywhere on that network if it really isn't needed. And so it helps harden our cores on an owner's network. So the security people encourage us to do that. So let's talk about network switch configurations. And so the easiest way to get a switch that's configured for Q-SYS is to buy one of our pre-configured switches. These are great for standalone single switch networks. It's by far the easiest way to do it. They're pre-configured for AES67 or Dante and Q-SYS endpoints. So you can't go wrong with that. It's simple, it's easy, so the hard work's done for you. Unfortunately, in the real world, we are forced to use other switches on occasion or need to coordinate with an owner's network, and they will tell us what switches that we have to use. And so that kind of kicks us out of our comfort zone a little bit. But what we do provide on our website is you can go to our document library. We have kind of changed where these are located recently on our website. But if you go to our support tab and then go into the document library, you can search for switch configuration files. And so there's a gaggle of switches there listed and the switch configurations that we recommend for those. Not only does it provide those switch configurations, you can also search for switches with known issues. So if we've run into switches in the past that have provided us issues, you can get a list of those as well. And there are some additional networking resources on that website as well. So I highly encourage you taking a look at that document library if you need to use non-Q-SYS Netgear switches for your AV network. And so let's see how am I doing on time. Oh yeah, doing great. So here's your real summary, the real takeaway, the sizzle reel that I mentioned before. This is basically a summary of where we see the most issues, as well as from our support folks. I polled them before we did this presentation, which issues do you see the most? And so they kind of gave me the highlights here. First and foremost, please keep in mind, all of this information is in our help file available at help.qsys.com. It's under the planning, Q-SYS compatibility networking requirements. Basically what this presentation is a summary of those points. But if you do need to do a deep dive about any one of these specifically, or you are coordinating with an IT department to put Q-SYS devices on their network, this is a huge resource. So please take advantage of this. Going to our second point here, make sure all of your network interface connections on your core processors do not have overlapping subnets. We see that more often than you would imagine. Again, and we also see gateways defined on more than one of those network interface connections. So please check for that. Again, gigabit speed bandwidth on your switches, even if you aren't anywhere near close to needing necessarily that gigabit bandwidth. Remember that gigabit speed helps reduce latency and jitter. And so please at least put gigabit speed switches on your network. Uh, Check your bandwidth requirements for uplinks. So those connections between your switches are quite often the bottleneck for bandwidth. So if you are especially doing video, Q-SYS video on your AV networks, you need to calculate those bandwidth requirements ahead of time. You do not want to find that out after the fact. We need to disable jumbo frames. Again, some third-party video platforms require that, but Q-SYS does not support it. We have gone through all of the various multicast requirements on all the protocols that require multicast. So IGMP needs to be enabled to manage the multicast traffic on the network. Fast leaves. Again, you want, especially if you're doing video, you need to enable fast leave on your network so that when you're making video route changes, you don't have those streams overlap and flood that 1 gig network connection. QoS, hugely valuable, in particular if you have more than one switch on your AV network. That QoS will reduce latency and even probably more importantly, jitter, so that those PTP clocking packets have a very consistent time it takes for those to propagate through your network. Switch hops, again, we recommend 3, but we do support up to 5. So do your best to minimize those switch hops. And another thing we see quite often, Q-SYS video endpoints require PoE++. If you do connect like an NV32 or an NV21 to a PoE plus switch, it will try to boot, and you can often even see it on the network, but trust me, it's not fully booted and it is not going to work. So be sure when you are specifying your network switches, in particular with Q-SYS video, that those are PoE++ connections. And there you go. I hope that wasn't too painful. Let's see, we got a few extra minutes. Are there any lingering questions in the Q&A? Let's take a look. I guess first I can see what we get. Oh, we got a few in here. See if I can answer a few of these. Yeah, feel free. Any questions you have, please pop those in the Q&A. We're going to try and get to those. I know we've got a few minutes here, so we'll try to answer as many of these as we can. Let's see. Yes, this presentation, we will provide this slide deck as well as a recording of this presentation when we're done here. And I see Frank is feverishly typing the answer to that question right now. Let's see. While Q&A is interesting, address concerns, it's hard to keep. Okay. All right. It's a little bit of a duplicate there. Let's say, yes, you will receive a copy of the presentation. What happens if there's more than one gateway defined? All right, so that's a good question. I'm just going to go ahead and I'm going to answer that live. So since the core processor has more than one NIC, if there is an IP address or even a web page, really, and that core needs to figure out which network interface connection do I need to reach out to and which gateway I need to reach out to make this connection, because I'm trying to connect to something that's not on the local area network. It can be somewhat random if there are multiple gateways defined, because there's essentially 2 paths for that core to reach out beyond the local area networks. And so a single gateway defined gives it 1 NIC and 1 gateway to connect and make that request, so that you know if it's needing to reach out to the internet or if it's needing to reach out to another device that's on a separate VLAN or a separate subnet, that core knows exactly which NIC it needs to make that request out from. All right. Jumbo frames not supported, but will work. Yeah, so jumbo frames, as long as those jumbo frames don't hit the core processor or peripherals. And so if you have multicast uh, support on your network so that those jumbo frames aren't routed to your core processor, you're likely to be okay. But it's just an issue we run into on occasion, so I wanted to make sure that was covered here. Let's see, what was so the switch config files. So if you go, there's a question here about where do they find those switch configuration files. If you let's let me go ahead and in my slideshow here, and then here's our venerable help file. Let's see, and so if you go to support document library, here's where you can do those searches. And so you can search here for switch config files or switches with known issues, and those search results will pop up here. So yeah, definitely check out the document library that's inside of the support tab at the top. So yeah, go to support and then document library. Good question. Good question. I often find that system requirements require the use of 2 or 3 LAN connections from the core. All of the networks have DHCP with reserved addresses. Having the ability to disable the gateway on the LAN on the core would be nice. That's true. Feature to add. I will take that up to product management. You are right. That's when some of these configurations can get tricky when DHCP is enabled on multiple networks. That is a true fact. Let's see. Any reason to use LAN A over LAN B for Dante AES67 or if configured, either is fine. Either is fine for LAN A and LAN B connections. They both support real-time data transfers such as Dante and AES67. One thing to keep in mind with QLAN audio, Dante, and AES67 is that your core processor has only one clock. And so if you segment your Dante, AES67, and QLAN audio onto separate VLANs or separate networks, those two networks, audio networks, will need to have the core processor synced to both. So that your core processor will need to be either the clock master for both or functioning as a boundary clock from one to the other. I highly, highly, highly recommend anyone that's wanting to do a deep dive and get a better understanding of PTP clocking, please attend or watch our clocking domains webinars. Uh, I was my first exposure to it was I was forced to teach it, and so I had to get up to speed on it. And I was shocked as to how much I didn't know. And so it's hugely valuable to understand those concepts. But yes, LAN A and LAN B both support those audio formats for Dante AES67. And so you can get creative if you need to separate that traffic. But just keep in mind your a core processor has a single clock. And if it needs to communicate on both LAN A and LAN B, you need to take that into account when you're setting up your clocking domains. Let's see. Are there any specific best practices when working with software Dante multicast flows in a redundant core scenario? Uh, redundant core scenario. Uh, no specific best practice outside of, so it's redundant cores, not redundant network. So if you're doing redundant cores, I like to verify that the backup core is functioning as the clock master. So when you do a redundant core processor setup, you have your active or your main core, and then you have your backup secondary core processor. They are going to send and receive all of those audio packets, and that backup core is still churning through all that math and doing all that processing. Although it's going to be quiet on the network, it's still receiving all that. So that if it detects when that main core processor fails or its network connection drops, it will jump in and try to create as seamless as possible a failover to that backup core. One thing that helps speed that up and makes it less disruptive, I'd never say it's perfectly seamless, but what would make it less disruptive is if that backup core processor is functioning as your PTP clock master, because if that main core processor fails and now you're relying on that backup core, at least all of the devices on your network do not have to reclock to anything new, and so the failover is faster. The alternative for that is if your main core is functioning as your clock master, if it fails, not only do you then have to fail over to the backup core, but all of the devices, all your QLAN amps and all your Dante and AES67 traffic will have to reclock to that, and it's a little bit more disruptive. So, in summary, just make sure that your backup core processor is functioning as your clock master if possible. These are great questions. I've moved completely to 2.5 and 10 gig switches. Where possible, I isolate my Dante traffic on its own switch network. Can this work for Q-SYS? Yeah, honestly, if you're doing Dante traffic on a network and you're doing QLAN as well, I would have your Dante and QLAN traffic on the same network. We can share the same QoS values, so your network switch configurations would be essentially the same. And so, yeah, with 2.5 or even 10 gig switches, now you're talking even less latency and less jitter. So, yeah, no problem at all. That'll work well. Let's see, how are we doing on time? We got a couple more minutes. Will Q-SYS switch profile ever be available for Netgear 4250 series switches? The 4250s are what we use. That's a great question. If we publish those, I guess, I mean, you could always pull a switch config off of one of our switches. That'd be kind of a left-handed way to do that. I'll have to take that up with product management actually to see if we decide to publish those. That's a good question. I'll have to take that up with product management. Thanks for that question. Uh, is it better to set up a network switch as the IGMP querier or allow the gateway to act as the querier? Set up a network switch as. Uh, I typically recommend setting up a switch as your querier, just so that it's not left up to kind of happenstance. Typically, switches will elect a querier often, but I don't tend to rely on that. Plus, when you dictate the querier switch on your network, you can then dictate that it's a little bit more centrally located on your switch, especially if it's a larger network with a lot of switch hops. Um, I don't think there's necessarily any benefit to your gateway acting as the querier. Be fine to do that. That won't generate a problem, but I'm not aware of any benefits of your querier and gateway switches being the same. Let's see. Yeah. Got just a few more minutes. The answers imply that the 110, as in the core 110 line, is being EOL'd. Yes. So the venerable core 110, pour one out for the core 110 has been replaced by the 24F. It's extremely similar to the 110. It just has more network connections on it, yay, and quite a bit more processing power. But as far as analog I/O, we brought GPIO back. I can hear the applause in the Q&A for that. And so yeah, so once 10 EOL, but take a look at our new bestest buddy, the Core 24F. It's got everything you loved about the 110 and more. I'm answering these as Jason Kleiman is typing. Sorry, Jason, I'm stepping all over you. Let's see. We've got, all right, we're about at time. I'm going to try and answer one more, and then we'll have to try and uh, take these up later. Would error messages show on NV32 status window saying NV is at fault because input stream LAN A streaming error packet missing? Output stream LAN A streaming error packet missing be an issue with QoS. Yes, that could be a QoS issue. If this is a current issue, I would contact support. I know we had an issue with a specific version of firmware that was throwing this error, even though it wasn't a problem. It was just a false error. It didn't actually exist. But please contact our support team to help troubleshoot it. But yeah, it could be a QoS issue, but it might also be just a false error. If the unit is functioning properly, but you're seeing this error, it could very well be the firmware version. So feel free to follow up with our support team. Again, thanks everyone for attending. I hope everybody got at least a little bit of information out of it. Again, refer to our help file for any deep dives, and hope to see you in the next one. See, thanks everybody.